calculations in vectors. Let's look at the first one. Okay, so calculate the net force acting on this block. So remember, it's the triangle rule, and this is where people can go wrong. Okay, so you draw in your first vector, and at the tail of the first vector you put the start of the second vector. Sorry, going down 5 newtons. Okay, and then from the you complete the triangle from the start to the finish. That's your resultant R, and this is your angle theta. Okay, indicate R and theta, because that will give the direction of the angle in your answer. Okay, and you remember you always use Pythagoras' theorem to get R, the magnitude. So the length here was 12 newtons. So the length of this, make it clear, was 12 newtons, and the length of this was 5 newtons. So R squared is equal to 12 squared plus 5 squared from Pythagoras. So R squared is 169. R is the square root of 169. So R is 13 newtons. The angle we get from tan. So tan of the angle is opposite over adjacent. Always show that. Write it in. Tan of the angle is 5 over 12. And we're going from tan of the angle to the angle. It's the arc sine, or the second function sine. So second function of tan, 5 over 12. Okay, I'm getting an answer here of 22.62 degrees. Since you've shown theta in the diagram, you don't have to explain this any further. You're saying it's the angle 22.6 degrees, and that's showing you the direction. Okay. Second type of question you need to be able to do for the basics is resolve the vector into horizontal vertical components, which is effectively the opposite of that. So we have a vector of 6 newtons, R is 6, and the R is 28. Draw in your horizontal and your vertical components. Okay, this is 28, and remember, the horizontal components, or the component beside the angle, is the cosine one, so 6 times, so R cosine theta, 6 times cosine 28, and this is 6 times sine of 28. It can be useful at times just to have this drawn, or this in your head. Okay, some people prefer to have that one to link it across. Okay, so again, you just your calculator, 6 multiplied by cosine of 28, so that's 5.30 newtons to the right, and 6 sine of 28, 2.82 newtons up. So if you add a horizontal to the right vector of 5.3 and a vertical vector of 2.82, you would get a vector of R equals 6 and theta is equal to 28. So basically the opposite of that. Now the next one here, and this is interesting, you're asked to resolve the vector into components parallel and perpendicular to the ramp. Now the important thing here is that the vector you're resolving has to be the hypotenuse of the triangle, and this is where people get caught. So in this case, okay, you want a component horizontal to the ramp, and you want a component perpendicular to the ramp. So you make your triangle. So that 8 newtons is still the hypotenuse, because that's the R back to here. R, the original vector, has to be the R, and you now have your 2 perpendicular components, one of which is parallel to the track and one which is perpendicular to the ramp. Okay. Now you have to do a little bit of trigonometry or whatever. 28, this is clearly 90 degrees, sorry, 20, this is 90, so this here is 70 degrees, isn't it? Okay, using that triangle, okay, because obviously the gravitational force is vertically down. Okay, so then parallel to ramp, perpendicular to ramp, parallel to the ramp. Okay, it's the one beside the 70. Okay, so it is 8 times the cosine of 70, and perpendicular to the ramp is the one opposite the 70, so it's 8 times the sine of 70, using that idea. So remember, the adjacent, the one that's beside the angle, adjacent to the angle, is the cosine, because you know cosine is adjacent of hypotenuse, and that's where you're actually getting it from. So 8 multiplied by cosine of 70 is 2.74. Okay, in the direction shown. here, okay, and 8 sine 70, 7.52 newtons. Okay, so that's 7.52 newtons, and that's 2.74 newtons. There you go. So that's how you do ones like that. The crucial point is, remember, if you're resolving a vector, the original vector that you're resolving must be the hypotenuse of the triangle. You won't go wrong if you do that. Now the third one here then is kind of linking them all. Okay, you can add vectors that are not perpendicular, okay, using sine rule and cosine rule. Now we don't do that in general, but what we can always do is just use this method, okay. And what I'm going to do here is I'm going to add 3 of these vectors together, and all we do is we're going to get all 3 horizontal components. This is kind of a mixture of the two. So we're going to do the horizontal components and the vertical components. Okay. Now, in those of you doing applied maths, talk about I and J's. Okay, we just talk about horizontal and vertical. So let's go through them all. Okay. So this vector, okay, I'm going to call that vector A, vector B, and vector C. This vector, its horizontal component is 8 times the cosine of 30. We arrive at that, 8 times the cosine of 30. That's vector A. And its vertical component is 8 times the sine of 30. Vector B, the horizontal component, watch this, is 3 times the cosine of 33, but it's negative. It's going to the left. So it's minus 3 times the cosine of 33. Okay. You could talk about being 3 times the cosine of 147. Okay, if you're thinking unit circle, but I think it's easier that we look at it and say that's minus, and we stick to the angles less than 90. Its vertical component is up, so it's positive, so it's 3 times the sine of 33. And this one then is vertically down, so it has no horizontal component, but its vertical component is 5 newtons. Down, and we know down is negative, so it's minus 5. Next step, okay, we can now add the horizontal components because they're all in the same direction. So we get 8 times the cosine of 30 minus 3 times the cosine of 33. Okay, and we get a value of 4.41 newtons. And that's clearly up, because up is the positive direction. We always consider up to be positive. In this one, we get 8 times the sine of 30 plus 3 times the sine of 33 minus 5. And we're getting a value of 0.64. Sorry, 0.63 newtons up, or sorry, yeah, up vertically. So what you do then, okay, is we now have a horizontal component of 4.441, so we just draw that in. We have a vertical component of 0.63. We need to add the two of these together to get our final component. Okay, put in our theta, put in our r, and we're back to we're back to this guy here. Okay, so Pythagoras' theorem to get the magnitude. Getting r squared is 19.05, square root that, and we're getting 4.36 newtons. And the direction, and we have the direction, the actual direction indicated. Sorry, I got down, I'll move this over. Tan of theta equals opposite over adjacent. Tan of theta equals 0.63 over 4.41. So theta inverse sine tan of 0.63 over 4.41 equals 8.13 degrees. Okay, and your angle is shown there. So just to recap on that, for any combination of vectors, you can resolve them all into horizontal parts and vertical parts. You've learned how to do that up here. You can then take the horizontal and the vertical and combine it, okay, into an original vector, like you did up here, and you get your answer. And you can do that with any vectors.